So far we've done a lot with spatial joins, but we haven't done the big thing that's probably on everyone's mind, building a choropleth. A choropleth is one of those maps where lesser values are lighter and higher values are darker. Let me load some up here. Population, crime rates, number of goats, average Yelp score. Whenever you have a bunch of numbers and a bunch of areas, whether they're states or neighborhoods or counties, people want to color code them. The problem is with the code we've done already, we don't seem to have the right setup in terms of geographic data. So if we wanted to do the number of power plants per state, we already have our join data here, right? This was our spatial join where it associated every plant with the state. So in order to find out how many plants are in each state, all we need to do is joined name value counts. And there we go, a list of state names and a list of numbers. The problem is, though, there's no geography. Well, what if we go back to our joined data? Okay, so we look at this and we say, okay, instead of this geometry, we actually wanted shapes. So your first impulse is going to be go up and redo your spatial join. So instead of joining plants to states, we'll do states to plants and make sure that it contains. So there we go. Our geometry is looking great. Each one of these is a state. And if we steal our code from before for the value counts, I'm just going to do the head because we know what it looks like. Because each one of these power plant rows has the name column of the state that it's in, California 122, North Carolina 461, so on and so forth. So we seem to have our geometry right here, and we have our value counts right here, looking good so far. So all we had to do, it seems like, was switch states and plants so that we kept the state geometry. Here's the problem, though. How many states do we have? Well, let's look at what happens when we joined this. If we look at our joined shape, in the data frame that we have right now, the geo data frame, it has 7,410 shapes. So it has over 1,200 shapes of California, over 400 shapes of North Carolina, almost 400 shapes of Texas, because every single one of these rows not only comes with the name of Alabama, it also comes with the geometry of the state that it's in. That's what we did by switching around the S join. Because it's the first parameter, that's the geometry that you get in the end. But we have 7,400 of these. We're mapping the continental United States. We only want 48 states on our map. We don't want over 7,000 states on our map. So in theory, maybe we could wrangle this and turn it down into 48 different geometries. But honestly, there's a much, much easier way. What we've been looking for is a geodata frame that doesn't have 7,410 shapes, but rather just has a shape, one shape for every single state. And if we go to the prep work that I did initially, hey, what about that original states shapefile, right? It was there. States.shape, it has 48 states. I can plot it. And look at that. These are the states that we're interested in. If only there were some way to combine this state data frame right here and this value counts right here from our joined data set. So What we're going to try to figure out is how to take this value counts right here and put it into this data frame here. So our original states data frame has a name, a population, and this beautiful geometry. And we just want a brand new column with this number of power plants. So if you have a geodata frame or a normal data frame, it's pretty easy to add new columns. So let's say we had a new column we wanted to call nothing. We could say nothing equals 1, 2, 3. And then, magically enough, we would have a brand new meaningless column that has 1, 2, 3 for every single state. That's not a very cool column though. What we really want is a column that's different for every single row. So in the same way that population is different for each row, we want something like that. Well, let's say we made a calculation for each state to get the population in millions instead of the population in normal numbers. We could say states population divided by 1 million. I'm going to get the head just so we don't have to look at too much of it. So our first one here, 4.8 million, 6.7 million, 2.9 million. So this is Arkansas, this is Arizona, this is Alabama. Nothing too crazy, right? It's different for each row, and as we already know from work that we've done before, we can take this calculation and save it back into our data frame. So I could say, states, you're going to have a new column called population millions. And I'm going to make it be equal to this. And then if I do a head, pretty easy, right? So it converted the population of Alabama to millions, population of Arizona to millions. Took the population of Arkansas, divided it by 1 million, and put it in that brand new column called population millions. Same thing for California. Took the population of California, divided by 1 million, put it in that new column. So the important thing here is, how did pandas figure out where to put the data? How does it figure out which row from here, from this calculation, on the right-hand side, how did it figure out which one of these lined up with this one of these? It actually isn't a result of everything being in order. So first, let's take a look at this data frame. So you might know this already, but the column on the very far left, this is called the index. It seems like it's just a row number that starts from 0 because maybe people are really bad at counting down from here. But it's actually a unique identifier for the row. It's the way that pandas can tell each one of these rows apart. It doesn't think of Alabama as the first row, Arizona as the second, Arkansas as the third. It thinks of Alabama as row ID 0 or row index 0. Arizona is row index 1. Arkansas is row index 2. If we look at our population calculation that we made earlier, we also see multiple numbers. We also see something on the far right. This is the same. It's an index. It's formatted a little bit differently, but it's still an index. And once again, this is how pandas tells each one of these rows apart. This is row index 0, row index 1, row index 2, row index 3. This does not mean the first row, the second row, the third row, the fourth row. They mean we got this population from row index 0. We got this population from row index 2. For example, let's say I took all of the states and then I sorted by population. So we can now see that instead of 0, 1, 2, 3, 4, we have 28, 26, 20, 24, and 6. So what has happened was these have all been reordered, but each one of these rows is still keeping the index that they're associated with, because once again, the index is how pandas can tell each one of these apart. So if I did the same thing and I just pulled out the population column, pulled it out as a series, you see these same index numbers are here. 28 here means this belongs to column or row 28. This 26 here means belongs to row 26. Not row number 26, but row index 26. So they're unique to the row the data came from, not just a way of counting up through rows. So indexes are so important to pandas and so important to knowing which row information came from that whenever you do this assignment here, we did it once, but I'll do it again. The way that pandas knows to match these up isn't first row, second row, third row, fourth row. It's, I know that this index here of 28 matches with index 28 in my target data frame. So it's saying, okay, let's find index 0 over here and match it with index 0 over here. Let's find index 1 over here, match it with index 1 over here. Index 2, index 2, so on and so forth. That's how it knows which rows belong to which. So let's bring this back around to geopandas. So we have two data sets, if you remember. We have the states data set right here, and we have this data set of value counts. So as we know, we can't just say states count equals that, because what's going to happen is indexes have to match when you're making these assignments. The indexes for the states are, as we've seen, 0, 1, 2, 3, 4. They're numbers. Indexes for these value counts, as we've seen, California, North Carolina, Texas, New York, even though these look like what we think of as real values, even though they're not numbers, these are still the index. Indexes can be anything. Dates, strings, numbers, everything is fine. So we need, if we want to take this information and shove it into this data frame as a new column, we need to have the indexes match. So if the states data frame had an index that matched California, North Carolina, Texas, New York, we would be able to just say states count equals that. It actually isn't that difficult. It's pretty easy to do this. So what we're going to do is we're going to take the state data frame and say, hey, you know that name column that you have? It's a pretty good column. How about you get rid of this index of numbers and replace it with the name column? The way we do that is states set index name in place equals true. So what we see happens is that left-hand column totally changes. Pandas throws away the existing index column and moves the state name over to the far left, making it the index. So if we, for example, pulled out the population column, funnily enough, now instead of having 0, 1, 2, 3, 4 on the left-hand side, this is the index column which was once the name column. So 100% indexed by name. So if we go back here, these are indexed by name. These are indexed by name. So if we take this value counts we can just say states power plant count equals, and it takes the keys, the indexes from here and the indexes from here, and matches them right up. So anything, let's just take a moment and think about how amazing that is. So we have all of this crazy joined data that is just full of nonsense, right? All of these repeating polygons, these repeating names, all of that. And all we had to do to force summary information out of that back into our original states data frame was just change the index of the states data frame. So pretty great, right? So the real fun part is now that we can do this kind of assigning here. We can assign anything back into our states data frame as long as it has the index of the state name. What I really mean by this is you can go crazy with group bys now. So if I take this join data, which is, again, every single power plant, first power plant, second power plant, third, fourth, fifth, each one of these power plants has a megawatts, the amount of energy that it puts out. If I wanted to say, hey, how much energy does each state put out? I would say, let's group these together based on the state name. So all the Alabamas together, all the Californias together, all of the Nebraskas together. And once those are grouped together, let's grab the megawatts column and add it up. It'll add it up for every single state. So we see Alabama has a certain number of megawatts, Arizona, Arkansas, California. See how the index here is the state name? And remember how the index on the states is the state name? So all we need to do now is states megawatts equals bam. And just because of the fact that this index right here is the same as this index, we can make those kinds of assignments. It's pretty exciting. But the real exciting point, the reason why we're doing this, we didn't need to assign this back into the data frame, the geodata frame of states, in order to know, right? We could read this and say, here's how many megawatts Alabama produces, here's how many megawatts Arizona produces. The whole point of this was to make a map. And so the way that we're going to make a choropleth now is we're just going to say, hey states, can you plot yourself? Which would just produce a normal boring graphic, colored according to nothing at all. But if we say, hey, when you're plotting, can you pay attention to the power plant count? What it will do then is it'll go through every single one of those states, and as it is plotting it, it will use power plant count in order to color the state. We can do the same thing with the megawatts column. Granted, I hate this graphic. I hate this color scheme. We have a lot of updates we're going to do in order to make this actually good. But we can now make our choropleths to say what states have a lot of power plants, what states have few, what have a lot of megawatts, what states have few. So now, one final thing before we're done. If we look at our states, there's a problem. You can't tell right now, but our name column has actually disappeared. It seems like our name column is right here, but if we try to say, hey, give me the name of every state, it's not going to work. It's going to give us a key error. It's going to say, I've never heard of the name column before. Even though we can point to it being right here, Pandas swears up and down that it doesn't exist. The reason why that column doesn't exist anymore is because it's the index. And once it becomes the index, that column is gone. But if we want it back in order to say, save this to a CSV or something like that, it's pretty easy to turn the index back into a normal column. The way we're going to do that is dot reset index in place equals true, so we don't have to make a copy of the data frame. And there we go. It even keeps the column name and everything. So this is the exact same as we had originally, but now instead of name being an index, or now instead of not having power plant count of megawatts, we now both have these new columns and name is restored to its rightful place as the index. The only problem is now we can't assign more things to this. We can't do more of those group bys like we did right here, because this key or this index is the state name, but our index isn't the state name anymore. But hey, if we want to assign more columns from our join data, we can always do that set index again, totally fine. But for now, we have a nice geo data frame full of data from our spatial join. So now we know how to use spatially indexed joined data to create choropleths. By manipulating indexes, or indices as we should call them, we can take group bys and value counts and feed them back into the original data frame. And once that information is in the original data frame, there we go. Totally mappable, incredibly easily mappable. Choropleths for days, looking great, as long as we change the color scheme, which we'll do later. So I do have to say that although we've covered the basics, there are a lot of other techniques and important gotchas that you'll need to know about, especially when recombining data. So in order to make sure you avoid common mistakes, I recommend checking out a little bit more of the information that I give you on this topic. But hey, it's looking pretty good so far, and I'm sure you can make a ton of beautiful graphics with what you know already.